Today we learned the room type air conditioner window type. In our daily life, we use the air conditioner for the cooling of the normal environment, to easy life and dealing to easy work. For the highest region, highest temperature region or the Calcutta region, in summer very hot. Therefore, we could not live at this temperature. Therefore, we use the air conditioner to remove the heat at our living environment or working environment. Now we go to the working principle of the window type air conditioner. First, there are four parts. Mainly, there are four parts which names are evaporator. This is the evaporator region. Is like a tubes which is inside of the room, and it spins like this. I like a pipe is suppose bend, or suppose lining, or suppose rolling is type. This is the fins type, and through this tube the refrigerant will flow. It will go through the compressor, another part is compressor, then the refrigerant go to the condenser. This is also a fins type, and it showing the fins are cooling environment. I like a seat type. I like a seat and fins are also combined together. And then when compressor some remove exposed to the air in the outside the environment, then the refrigerant comes to the expansion valve, and now after passing through expansion valve it will go through the evaporator. There are four parts: evaporator, compressor, condenser and expansion valve. This is the requirement. Because there are four parts, we can note the complete cycle of the AC work. Now first we go to evaporator. Evaporator is a fan will rotate continuously. I like a fans. It will rotate continuously. A parting wall is here. The outside temperature is about 45 degrees Celsius. This is the parting wall outside temperature, and parting wall is another work is the parting wall inside temperature is 25 degrees Celsius. It will maintain then not mix the inside and outside temperature. Okay. Then the fans are rotated, then receiving the heat, receiving the hot air and circulating the hot air, and touch this is the cold tubes, cold fins, which is coming from the expansion valve, which is coming from the 5 degrees Celsius to 10 degrees Celsius. Then the 25 degrees Celsius air is touches the fins of pipes, tubes. It will cool, and approximately it will cool. Some heat is taken through the to the latent heat. This is the refrigerant of the tubes is taken the heat from the latent heat of vaporization. The inside temperature through which the latent heat of vaporization they receive the heat, hot air heat is received through the pipe, and it will goes to through pipe and goes to the compressor. No refrigerant contact with our air. Only the latent heat of vaporization is working, because the tubes is touches to the air, and inside of the fluid it will go, which temperature is 5 degrees Celsius. Our temperature is 25 degrees Celsius. Therefore, the temperature gradient, it will release the heat, cold air, to the room as approximately 15 degrees Celsius. This is showing here, supply air to the room at 15 degrees Celsius. Now, here the evaporator portion, when the receive the heat through the tubes, it will goes to the here the low pressure vapor at 10 to 20 degrees Celsius, because some heat is received, therefore its temperature some high. Now its value is 10 to 20 degrees Celsius. But it is in vapor stage, not in liquid stage. If liquid stage of the refrigerant goes to the compressor will working very low time, and it will failure within 6 months, 1 year. If the compressor working 10 years, then it's coming to the refrigerant is in vapor stage, but its value is low pressure, as like 1 bar or 1 bar below 1 bar. Okay. Now the compressor is compressed the air. When compressed the air, what happens? If volume is V1, then it will shorten the air. This is the volume is reduces. Then compress is compressed. Then suddenly its pressure is high, but it's coming the low pressure refrigerant and goes to the high pressure refrigerant, and the temperature is very high, about the 200 to 300 degrees Celsius. This is not written here, as we solve the questions. Then there some parameters are given, and we calculate the temperature variant. Then we know that how much temperature it will have. Okay. Then the high pressure vapor is inside high pressure vapor of the liquid, high pressure vapor of the refrigerant. It comes in contact with the condenser. The tube is coming as like the fins like, and the high pressure vapor of refrigerant is goes inside of the tubes. It will flow, and the condenser work is what? Any type of the condenser work is used for the cooling of the refrigerant or environment is type. Condenser work is the cooling of the system. Only this working. From this figure, the outside temperature is like a roof. Outside environment is 45 degrees Celsius in summer. Okay. When here the fan is forcing it, forced fan, and forcing it the air circulation high speed. Then what happened? Here the high pressure vapor comes in contact due to the latent heat of the vaporization. Some heat is received. This heat is only released. Here the heat was where the refrigerant is received the heat from the evaporator, and same amount the heat will release through the condenser as our cooling medium of the air. Here not a cooling medium of the water. Okay. This is the cooling medium of the air. Air will circulate continuously, and it will flow forced type of air. Not natural air is this, but the fan is used for this is the forced draught or the forced air. Then the temperature it will some receive the heat here and release the here. Then this type when the release the heat, then this environment temperature goes to 45 to 55 degrees Celsius. Now, when release the heat of the refrigerant, then the refrigerant will transform to vapor to liquid. Okay, understood? Transfer to vapor to liquid. This is the after condenser, the refrigerant is in liquid state, but the compressor is applied to the compressed and it will goes to the high pressure, then it is in high pressure region. Liquid state is about 60 degrees Celsius suppose, and the pressure is high. Okay, after that, when the pressure is high, our work is when the coming to the evaporator, its pressure will low. If the pressure low, then automatic temperature will fall. Okay, then we use the expansion valve, and in refrigerator where use a capillary tube, पतला ट्यूब दे दिया जाता है. ओके, पतला ट्यूब दे देने से क्या होता है कि आपका मान लीजिए यहाँ पर रास्ता है अधिक जाने, बहुत सारे आदमी है, लेकिन यहाँ एक ही आदमी के जाने का रास्ता है, तो क्या होगा, जो फ्लूइड जो है, जो हमारा रेफ्रिजरेंट जो है यहाँ फ्लूइड रीजन में है अभी, है ना, लिक्विड रीजन में, तो वो फ्लो होगा स्लोली होगा, तो उसका प्रेशर ड्रॉप हो जाएगा, और वो प्रेशर अप्रॉक्स एटमॉस्फेरिक प्रेशर से नीचे भी चलेगा, लो प्रेशर रीजन में रहता. ओके, नाउ द एक्सपेंशन वाल्व इज ओपन. ओके, द प्रेशर क्या हो गया, इधर में बहुत हाई प्रेशर था, सडनली गेट खोल गया, द ओपन द गेट सडनली, देन इट विल गो करके सब भाग रहे. ओके, तो हियर नो प्रेशर, एक्सपेंशन वाल्व ओपन एंड द प्रेशर रिलीज. ओके, नाउ द लो प्रेशर टेम्परेचर, low pressure and low temperature in this region when the expansion valve open, and the liquid is in a state of 60 degree to 10 degree Celsius, which is less than the our room temperature. If we cannot come to release the heat from the expansion valve is less than 25 degrees Celsius, then it will no work, because our room temperature is also 25 degrees Celsius. Then our necessary action to the fluid is comes in contact to the evaporator before it will comes in less than our room temperature. Therefore, pressure is extremely reduced and the extremely less in low pressure. Therefore, the temperature is 5 to 10 degrees Celsius. Then again it will goes to the evaporator, it will receive the heat due to the latent heat of vaporization, and it works, then go to the turbine, condenser and expansion valve, and it will continuously rotating the work. And this the evaporator, compressor, condenser and the expansion valve, our circuit and our full circle is completed. For running of the fan and the compressor, our requirement is a electric power. To rotate the compressor, we use the motor to supply the power to the motor, and motor will rotate the pump as well as compressor. Okay? Okay. Now the refrigerant R22. Refrigerant is R22. Trade name Freon. Okay, this is the scientific name is CHClF2, mono CHL or chloro, difluoro methane. monochloro-difluoromethane. Okay, this is the refrigerant. We use this refrigerant to work this temperature is 5 to 10 degrees Celsius. It will be high at the about when after passing through the compressor, it will goes to the 60 degrees Celsius. And if the air conditioning unit is used in a large capacity of the work, like industry, there will evaporator, compressor, condenser and expansion valve are same, but only one difference is that the condenser is cooled by water in industry. Okay, normal air, condenser is cooled by air. Here cooled by air. COOL, cooled by air. Normal air जो in our offices or room में जो भी चल रहा है, this is cooled by air, but in large size of this, then the condenser will flow. Condenser will make like a fins. Then the water will flow like a pipe. Then it will release the heat and receiving the heat and goes down. And in industry, okay, now stop. Now the next part is the domestic refrigerator, the schematic diagram of the domestic refrigerator. First, our domestic refrigerator is used for the storing the food, which temperature is environmental low the environmental temperature. Therefore, a long time our food will not destroy. लंबा समय तक हम लोग को अगर इस फूड को अच्छा से रखना है सेफ्टी में, तो उसको हमको रेफ्रिजरेटर के अंदर, ऐसे हम जनरल भाषा में उसको फ्रीज बोलते हैं, फ्रीज के अंदर रख देते हैं. रखने से हमारा क्या होता है कि इसका टेम्परेचर, फूड का टेम्परेचर पहले इन्वायरमेंटल टेम्परेचर में रहता है, बाद में हम उसको इसके अंदर में रख देते हैं. इसके अंदर में रखने से क्या होता है कि ये हमारा सर्किट जब ये चलते रहता है, हमारा फ्लूइड जब फ्लो होते रहता है, तो इसका अप्रॉक्सीमेटली जो फूड का जो टेम्परेचर है वो 7 डिग्री सेल्सियस के टू 10 डिग्री सेल्सियस के अंतर्गत आ जाता है. तो उसके अनुसार से ये चलता है. अब when the food temperature is 7 degrees Celsius when circulating, then here the natural convection will occur. नॉर्मली जो है कन्वेक्शन का काम है क्या, गर्म हवा को, नेचुरल कन्वेक्शन के अंदर गर्म हवा ऊपर की ओर जाता है और ठंडा हवा नीचे की ओर आता है, जो नेचुरली है. जैसे आप हम आउटसाइड जो बाहर में हम लोग का टेम्परेचर गर्म होता है, तो क्या होता है, नदी का पानी ऊपर चला जाता है गर्म होकर के, वाष्प होकर के, फिर बाद में वो कंडेंस होकर के फिर बारिश होता है. और जब वो वाष्प होकर गर्म जाता है तो ठंडा हवा नीचे की ओर आता है, धरती की ओर. देन सेम प्रोसेस इज हियर in evaporator. When the capillary tube is used for the expansion device, because here the high temperature liquid comes from the condenser. This process is as well as the AC type of domestic type of the air conditioner. Now we will continue to the previous part. Then the high temperature liquid, it comes in contact to the capillary tube. Therefore the capillary tube is not to flow the overall all the refrigerants or fluids, through which it comes in contact to the evaporator coils. Evaporator coil, when the liquid passing through the capillary tube, its pressure is low, but it is in a liquid region. Then the liquid of the fluid, it will pass through the coil of the evaporator. Therefore, when the liquid, low pressure liquid, its temperature will go down, very down, it will like to 25 degrees Celsius, minus 25 degrees Celsius, very low. And our environmental temperature is plus 25 degrees Celsius. Now the minus 25 degrees Celsius, then it will go up as like, and it's received the heat from the food. Due to the natural convection, here the some hot air is comes in contact to the flowing of the tube of the evaporator, and due to the latent heat of vaporization, its some heat is received and it will heat and its temperature will increase at minus 25 to 15 डिग्री सेल्सियस, minus 25 डिग्री सेल्सियस में अंदर में आता है और वो सम हीट को लेकर के minus 15 डिग्री सेल्सियस से बाहर निकल जाता है. That time the pressure is also low of the refrigerant, but the liquid form it goes to the low pressure vapor form of the refrigerant. In the 2000 era, R12, which is the normal name is chlorofluorocarbon CFC, but the scientific name is dichloro-difluoromethane, Cl2F2. But our AC, where the R22 is used, this is the monochloro-difluoromethane. We have discussed in this lesson in the earlier part. Now, in this era, we not used due to the R12 is very dangerous gas, where is used in the refrigerating machine. Therefore, the gas is destroy the layer of the ozone layer, which is the formula is O3, which is protect the ultraviolet ray to comes in contact to the earth in our body. Therefore, the ozone layer deflection in some big hole or any layer of the destroy due to the freon 1,2 or any this type of the gases. Therefore, it will not use in our era. And why? Because the ozone layer deflection due to this gas. This gas name is freon 1,2 dichloro-difluoromethane, and another name is the chlorofluorocarbon also, R12 CFC. Now, the low pressure vapor comes in contact to the compressor. Here the vapor is compressed, and here motor and compressor it will combine together, and the compressor is compressed to the refrigerant is in vapor state, and it will goes to the high pressure. When compressed, then it will go to the condenser, and due to the natural here also the natural convection, and the 25 degrees Celsius air comes in contact, and it will fins like this or a plate type. In a plate, and plate is like a fins, and there the tubes are welded or connected, and through which the natural convection it will goes to low temperature and release to the upside, which is the high temperature. Here also natural convection, and outside of the body is also release the heat, and it will cool due to the high pressure liquid. When the high temperature to high pressure liquid, and in this liquid region the refrigerant will go to the capillary tube, and capillary tube to the freezer or evaporator, and then go to the compressor, and therefore after compressor it will goes to the condenser, and the full circuit is continuously running as our requirement. When the required for the compressing the air, then the compressor will on, and not required for the compression, then that time compressor is off. In the summer time, the power consumption is more as well the winter season, because that time low temperature in the environment. Therefore, the compressor will work less hour, In the in summer, compressor will work continuously, and then the more power is required. Now, in the presence of the time, the Freon 1,2 is released by some refrigerant. I will remove the part and written here. In our domestic refrigerator, the rotary or reciprocating type compressor we will use. Our refrigerants are 1,2. This is the R12 is the difluoromethane, which is replaced, and it will bind due to the ozone depletion layer. And there are three refrigerants is written here. First refrigerant is R290. This name is propane C3H8. Another refrigerant which is generally used in our AC also is used in AC also. R134A. Refrigerant 134A. This scientific name is C2H2F4. Terafluoroethane. Terra. This is tetrafluoroethane. Are written some wrong here. Now they stop. We will correct. Refrigerant R134A. This scientific name is T2H2F4. This is the tetrafluoroethane. And the another refrigerant is 600A. R600A. This is the isobutane C4H10. We will use the environmental. This is the good environmental refrigerant. This is safest of the environmental, and this refrigerant R134A tetrafluoroethane is generally used in our air conditioner as well as refrigerator. Here the natural convection, some heat is received from the cold chamber of the food, and the here temperature will goes up slowly, which is the natural convection, and from the cool air it goes down through the evaporator, slowly go down. This is the evaporator unit, and that's just below the evaporator units. This is the freezer unit below the chiller tray, and below the some compartment, and in the least part of this portion, which is the vegetables compartment, and the very here the temperature is very low, and here temperature is high. If this part is the freezer cabinet, freezer inside temperature flowing through this. Okay, thank you.